Hello friends, welcome back. Hearty welcome to you. Let's look at this permutation combination problem. We have to find out the number of 7 digits, 7 digit integers with sum of the digits equal to 10 and formed by using only the digits 1, 2 and 3. Let me repeat it again. We have to find out how many number of 7 digit integers can be with a condition that the sum of all the 7 digits equal to 10, and we have to use only the digits 1, 2 and 3. So our approach is two steps. First step, we have to find out what are those different combinations of 1, 2 and 3 which will add up to 10. Once we know the combination, then we can easily find out the number of words, because we have 7 slots to be filled by using 7 numbers. That means it's nothing but factorial 7. If there is any repetition, we will divide by that repetition to make sure that we get the exact number of words. Now let's look at those combinations. Let us take first 3. How many 3's we can have so that we can have add up to 10? So 3 multiples less than 10 starts with only 3 3's. So 3 4, 3 5, 3 6, 3 7 are ruled out. I can have, let us say, 3 3's. 1 3, 3 3, 9. Remaining 4 to be filled with 1, so ruled out. I cannot have 3 3's, ruled out. Then can I have 3 2's? Can I have 2 3's? Sorry. If I have 2 3's, I have to fill 4 slots. That means one more slot is needed still. So I cannot do that too. So let me go for only 1 3 now. I'll see. If I go for 1 3, I have to fill 7 here. So for that, what I can do, I'll start with 1 1 1 1 1 4, remaining 3. Can I write it as 1 2 and 3? So this is one combination we found out. That means there are 5 1's and 1 2 and 1 3. Now the next combination, this is only the thing what we can do with the 3. So then we will go to 2's and 1's. We will see. If I go to 2's, I know 2 5's are 10, 2 4's are 8, 2 3's are 6. When I go to 2 3's are 6, I have 4 slots to be filled. If I go for, I cannot go, certainly more than 4, because 2 4's are 8, 3 slots to be filled with 2 1's. That means one slot is becoming unfilled, right? We cannot take care of that. So let us try for 2 3's. If I go for sorry, it is 3 2's. If I go for 3 2's, what is left out? 4 slots are left out. So that I can easily fill with 4 1's. So these are the only combination we can have where we can have sum equal to 10. Where we can say that you just add them up. That's equal to 10. So these are the two combinations. How we arrived at them? We have started with 3. We know that if I take 3 2's are 6, 4 slots to be filled with 4 1's, but 1 is empty. That means anything other than 1 3 remaining all are ruled out. If I take 1 3, then 7 is left out. 7 can be filled by 5 plus 2, or it can be, so can I say 5 1's and 1 2. Now after that 3's are over, we went to 2. Now 2 5's are 10, 2 4's are 8, 2 3's are 6. 2 4's if I go, then I have 3 slots to be filled with 2 1's or 2. That means one box is still empty. So I cannot go for 2 4's, but I can go for 2 3's. When I go for 2 3's, I have 4 1's left out. This is the only combinations which are valid, because if I go for 2 2's, I have 5 boxes to fill with 6. There is no other way I can do that other than 3 2's and 4 1's. So these are the combinations or the possible scenarios. Then how many words we can have, how many actually integers we can have, 7 digit integers from these two combinations. Let's look at that. The first one is 7 digit it is, but 1 is repeating 5 times. So we know that actually if there is no repetition, it is 7 factorial, but since 1 is repeating 5 times, that is 7 factorial by 5 factorial. Now let's go to the other one. Again it's a 7 digit integer, so factorial 7 divided by 2 is repeating 3 times, that means factorial 3, and 1 is repeating 4 times, that is factorial 4. Now we have to find out these values and we have to add so that we will get total how many number of 7-digit integers we can have with the given conditions. First, what is factorial 7 by factorial 5? Factorial 7 divided by factorial 5 is equal to 7 into 6 into factorial 5 divided by factorial 5, which is equal to 42. So first combination is giving me 42 values, 42 integers. Let's go to the next one. The next one is factorial 7 by factorial 4 into factorial 3. Can I write it as 7 into 6 into 5 into factorial 4 divided by factorial 4 into factorial 3, which is equal to 6. Factorial 4 will cancel, 6 and 6 will cancel. We are left out with 35. So 42 from the first one and 35 from the second one. So the total 7-digit integers are nothing but 77. Let's recap how we have solved this. We have been asked to find out the number of 7-digit integers with sum of the digits equal to 10 and formed by using the integers 1, 2 and 3 only. Now we looked at the combinations. So our sum is 10, that means I cannot have more than 1 3. If I take 2 3s, then I have empty slots. That means I have to go with 1 3 and try to fill the remaining 6 boxes with 7 value. That can be done by 5 1s and 1 2. So 3s are over. Then we went to 2. We checked that if I take 2 4s, then 3 boxes to be filled with 2 1 values, 1 box is becoming empty. So the only option I have is 2 3s. It's again apologies, it is actually 3 2s. 4 2s is ruled out, so it's only 3 2s. If it is 3 2s, then I can fill the remaining with 4 1s. So these are the only 2 possible cases. So when in competitive exam it has been asked, we have to be sharp enough to think about the scenarios, rule them out, and if it is a multiple choice question, then you have to look at the answer and see which one matches with you, whatever the value you got. Now once we know the combinations, then it is pretty easy, because we are interested in the integers. That means order is important, that means it is permutations. If it is permutations, it's nothing but 7p7 or factorial 7. But there are repetitions, so we have to take care of repetition. That's why we have to divide with how many times a particular digit is repeating. So that's how you got the value 42 plus 35 equal to 77. So I'll catch you once again with another interesting example. This is a problem which was asked in IIT 2000. 1 minute. I don't exactly remember the year. 2009. So I'll catch you once again with another interesting example. Till then, keep smiling. Bye for now.